Welcome to Code Club. This is where we read some Go code and talk about it. This week it's very exciting because we have a project from one of my mentees, Thibaut, who'll be joining us shortly, I hope, to talk about his project. But we can have a look at it in the meantime. It is a chat server, and if you're learning Go, you'll come across lots of examples of chat servers in tutorials and courses and things, and it's not surprising because it uses a couple of things which Go is good at: network server and also concurrency. So if you haven't seen one of these before, let's just try it. I'm going to run it, and I hope it works.
It will work.
Yeah, that's the spirit. Hey Thibaut. Yeah, we're just doing the demo, so you better hope this works. Right, the server is running. It's listening on 8080. Let's connect to it. Ooh.
Hello.
Howdy. Marvellous. Enter my username. Okay, Bitfield joined. Alright, let's connect someone else. Mystery Man. Hey. So I can see Mystery Man has joined. Hi Mystery Man. Yeah, this is great. I can talk to myself all day. But that's kind of neat, isn't it? So now we know what it does. Shall we start pulling this thing to pieces and take a look at the code? That's what we do, isn't it? Okay. Where would you like to start? We have a main.go. How about starting there? Any thoughts on this?
Did it again.
Are you?
was on mute.
You're in mute land. Yeah, it's a lonely place, isn't it?
Oh yeah. Oh, I could start here.
Go ahead.
So we're in package main. We've got some imports. We're importing a log. We're importing from a Git repository the envelope package, I'm assuming. Then we jump into the func main, or the main function. We do a log.fatal. Then we call package envelope listen and serve at the local host address on port 8080, which would start up our connection at localhost on port 88.
Yeah, sounds believable. And what happens then?
We're listening. If it fails, it'll log that error. Let us know that it didn't fail, and it'll cut the line.
Yeah, so it looks like listen and serve doesn't return, does it, unless the server actually closes down for some reason. So that's a really nice pattern. I mean, this is a beautiful main.go. This is how I think every main.go should be. If it's more than one line, I'm starting to question, why do I need multiple lines to get this thing running? You know, whole idea is I should be able to just import the library and call some method on it that's just like, go do the thing. And that's exactly what we have. And the name listen and serve is familiar because it's what HTTP uses. So similar to if you just want to write a basic web server, you can just write log.fatal http.listen and serve some address. So that's really kind of nice, isn't it? When you think of all the other ways that this could have worked, I think this is the best one. You know, you could imagine maybe you create a server object, you call envelope.newServer, it returns server an error. You set configuration on the server, and then you call something like server.listen, and then maybe you have some way to wait for the server to finish so we can exit. Maybe you listen to a channel or something like that. But that's a ton of paperwork, and you know how I don't like to do paperwork, or I don't like to make users do paperwork. So this is really rather beautiful. And you can see we pass in the address here because you could ask, well, why do we need the address? Because it's obviously going to be this machine. So you could say just listen on all interfaces, and maybe the port number is fixed too. Can anybody think of a reason why we might not want to do that?
You might be running multiple things on your local host.
Bingo. Yeah. I don't know why everybody chooses port 8080, but they do, don't they? So that's almost certainly busy with something or other on a dev laptop. And, you know, for whatever reason, I mean, I may not want to listen on all interfaces. I may need to listen on localhost or whatever. And the other thing is for testing, isn't it? If we're running a bunch of parallel tests, each test will probably want its own server, and so therefore they'll need to be on different ports. So this is very useful. So let's dive in and take a look. Let's look at listen and serve. Okay, Tom, would you like to start walking us through this, and we'll see what we can figure out?
Sure. So we know that listen and serve essentially returns the result of calling listen and serve with logger, which sends in the address that's provided to listen and serve and generates a new log that pointed at OS.standard error. So that anything we output presumably is going to go to that, or anything we call log with is going to go there.
Yeah, why would we want to do that? Why not just always log to standard error?
I mean, that's essentially what's happening, right? Like, there's no way to set this differently, correct?
Yeah, what I mean is...
Well, I mean, sorry, given this implementation, right? Like, if I don't call listen and serve with logger, this is what I'm going to get, right?
Yeah, absolutely. But what I mean is, why would you ever want to customize the logger?
Oh gosh, so many reasons. So like people will handle logging differently. So if you're designing an application for, you know, anybody to use, they're gonna have different needs as far as logging is concerned. They're also going to want to use different. They're going to want to use different methods and perhaps different loggers as well.
Yeah. Yeah, that's right. So particularly with libraries, the whole point of them is to be used in someone else's program. And they may have their own logging setup. They probably will. So if you just start logging to the default logger, that's going to be a problem for them. Partly because your log messages are not going to wherever their logs go, but also because they're probably going to the terminal. And, you know, if you're writing a command line application, you don't want some library printing all over your terminal. You may be doing some beautiful ASCII art interface or, you know, maybe display map terminal or whatever. So I see this a lot in Go libraries, that they just kind of, you know, print to the terminal in a devil-may-care way. It's like, you know, I'm just going to write all over your terminal. Hope that's okay. So Thibault has very politely provided a way for you to inject your own logger, but it's worth noting that he doesn't require you to do that. So if listen and serve with logger were the only thing there were, and you just wanted to write a very, very simple main.go that just says, yeah, I'm fine with logging to standard out or standard error, that's okay. Don't make me pass in the standard logger myself. That would be dumb.
Is that something that should be in the comments for listen and serve? Is that, and I'm asking that not as that's not a leading question. I'm just curious. Is that the kind of thing? And it's very easy to read that that's what's happening in code. But like if you were to put together a doc or something off this, would that be something you want to show?
Yeah, well, you can ask the author himself. Thibaut, what do you say?
Yeah. Well, by thinking about it, I I think that it would be maybe a good thing to put in the README, but I'm not sure, and that I forgot to mention in the README. So I don't know. Maybe in the comments or in the README. I don't know, or
Yeah,
both.
yeah. One thing about the comments is, of course, they'll show up in your
Yeah.
auto-generated documentation. If you look on package.go.dev, for example, you'll see that there. So you won't see the README. So
Yeah.
if you're searching on there for a chat server package, you might find this and you might say, okay, listen and serve. But I agree. I think it's something. It's always worth saying what your logging setup is. Like if it logs to the default logger, say that. If you have a choice of that or using your own logger, say that. But if you don't say anything, I think it's a safe assumption that the app is going to log to the standard logger, so that's not unreasonable. So inside listen and serve with logger, we're passing in a logras.stud logger. Does anybody like to comment on that? Anybody know what that is?
I know it's on my list of things to follow up on, as far as a standard logging library. My understanding is it's an abstraction over logging that would allow that's commonly used that would allow cover most use cases for logging.
Yeah, so we could have said, is it log.logger? Something like that. I think the standard library logger is not an interface, is it? It's a struct type which you pass around a pointer to. So things often take a pointer to log.logger. Does anybody know what logras is? Or has used it?
I've never used it, but my understanding is it allows you to pass in fields that you can log against, or parameters.
Yeah, that's right. It's basically a logger for structured data. So, if you're writing some kind of server, you probably want to log things about requests and stuff that's happening. And it's really boring to kind of have to construct a whole log line with sort of log.printf. The IP address was this, the request ID was that, the URL of the request was something, here's the body of the request, here's some other information about it. Imagine having to do that every time you log. Logras effectively just lets you pass in a struct and just say, log all of this in a structured way, with the field names and separate values and so forth. And the nice thing is it's completely compatible, API compatible with the standard logger. It behaves exactly the way you're used to, except that it has some new methods that you can call. And even more nice, they provide a couple of interfaces for you. So logras.studlogger can be satisfied by the standard logger, as you might expect, and a logras logger. So, whoever's consuming your library, if they're using the standard logger, they can inject one here. If they're using a logras logger, they can also inject it here. By referencing standard logger, what we're saying is we're not going to be calling any of the logras specific methods. So we're not going to be using with fields, for example. So we can take a logras, but we're not requiring one. That's the point, isn't it? Right, Mike, would you like to continue?
Sure. A variable s which points to our server struct. Yes.
Okay, here's our
This
server
includes
struct.
our logger. our listener, clients register, unregister, which is pretty much below that.
Yeah.
We have a welcome message,
Yep.
which we see on the screen, which is a pretty great logo.
Yes.
Then we start to set up our logging information with the server that we're connecting to, the struct that we're pointing to, excuse me. We set our logger equal to logger. We register a channel. That points to a connection.
Okay, that's what a connection is.
Yeah. And we do the same when we unregister. We point to a net.connection. I guess that where that connection is running, that would return maybe its UID or something, so we can stop it.
Oh. It's a net.con it represents an existing network connection, so we can read from it, write to it, close it, etc.
Then we create clients, which is a map of those connections, their strings or their values are string. Create.
Yeah, not sure what that's about yet, but maybe we'll figure that out. So let's continue.
We make a channel. That's interesting. I've never seen that written this way. Channel string 10.
So you know what that means?
10 channels that consume the messages that are going across.
It's actually one channel of string, but it has 10 slots, 10 buffer slots available. So, if you might know, if you have an unbuffered channel, if you try to send to it, you will just block until someone's ready to receive.
Okay, so each channel gets 10.
Yeah, and clearly, if you think about it, we wouldn't want that for a chat server because suppose we want to broadcast some message because someone said something. We send to that channel, and we don't want to be blocking on that send until some client is ready to receive it. That would jam up the whole server. So the server needs to just hand off that message and carry on. So that's why we have a channel with slots.
That makes sense.
Yeah. Okay.
I have a quick question.
Go ahead, Tom.
Why? So when you're creating your server struct here, or your pointer to it, why set only the welcome message in the when you're initializing or defining your server versus doing it all outside of like you are with logger and making your channels and whatnot? Is there a reason? Is there a pattern I don't understand as far as like how you should generally do those types of things?
Thibaut, any thoughts on that?
Well, basically, if I remember well, it was because the make statements, I was not able to put it within the struct declaration, but I'm not sure. And for the logger one, is just we could move it inside of the logger one. How's that? It's working also, so
yeah, that's okay.
it's just I
don't
know why I did it this way, but
I'm messing up your code.
Yeah.
Sure. I'm just curious if there was a pattern I was missing. I do certainly understand, like, your listener, when you're creating that, you're going to have to error handle, and you wouldn't do that in the creation of your struct. And I could certainly understand. I don't know what if the result of make is works when you are initializing your struct or not.
But,
in fact, online I saw the two versions, that sometimes people are just creating an empty struct and then they are setting the fields below it.
Yeah.
or sometimes they're initializing both in the same statement?
Yeah, it's a really good question. I think this is more about what's clearest and lets you set out your code in the most logical way. So, it's nice to be able to just set things directly in a struct literal. However, if there's any logic, of course, in computing those values, you're not really going to be able to do that. You can only have expressions here. As it happens, we do, but maybe so like here, for example, we couldn't do that because we have to receive an error from net.listen. So yeah, we probably could put these make expressions into the struct literal. I haven't seen that a lot, to be honest. I think if it's something like this, people are probably happy to put that inside a struct. If it's something like a function call, people usually write that outside the struct definition. And I think that probably looks a bit nicer. I think we sort of instinctively feel, don't we, that if we see a struct literal, we're probably just going to be assigning a bunch of literals or variables. Once we start calling functions and having logic, then it's a bit too much for one struct, isn't it? So we call net.listen, and that returns, so this is the standard library net package. It's actually quite unusual for people. I mean, it's very common to write network servers in Go, but they're usually HTTP servers, aren't they? Mm-hmm. Most of us probably written an HTTP server in Go. Most of us probably haven't written any other kind of network server. So it's interesting to do that. It listens on a certain network and address, so TCP is usual. And it returns a net.listener object, and that doesn't have any user serviceable fields, I think, but we can call, well, let's see what we can do with it. So we check the error. So if that succeeds, we know we're able to listen. If the port was busy, for example, we wouldn't be able to. We log to our logger, and then we call s.run. And then we return. So this is, so clearly this is not going to return until we're done, at which point we return nil error, we're back to here, and then we exit. So that's reasonably clear, isn't it? We don't know what all these things do yet, but at least we can see how they're being set up. Any questions on that so far?
I'm still, no, I guess I get that. I can make a channel strings.
Yeah. Let's dive into run then. And we'll see what happens. So we've seen this already, but here is run. So would anyone like to have a go at this? Because this looks like a bit of fun, doesn't it? This looks like this is where the real stuff is happening. So who feels up to narrating this one?
Happy to give it a shot.
Go for it.
So this is a function on my server struct.
Yep.
So the first thing I'm going to do is I'm going to kick off a new Go routine, or I'm going to run s.listen inside a new Go routine.
Mm-hmm.
I don't know if we want to go down to listen there, or you want to move on in this function.
Yeah, let's do that. Let's look at listen.
Okay, so listen is going to run, essentially it's going to, we have a kind of an unparameterized for loop, meaning I'm just going to run until this thing, something makes it stop.
Yeah, it's characteristic of servers, isn't it?
Mm-hmm.
Just listen forever.
I'm going to set a variable con to the result of accept off my listener, which is, I'm just reading what you have highlighted. So it returns the next connection, right? So when it's waiting for an incoming connection once I get one, right? So if I call accept, I'm just going to wait there until I get a new connection.
That's right, we block on the call to accept. We're listening on port 8080, and when someone makes a connection to it, accept will return a connection object for them.
Yeah.
And we hope that didn't error.
Yeah.
What do we do next?
So the next thing I do is I'm going to print out basically a welcome message to on the connection that just came in. So I've accepted a new connection, and I'm going to print out, hey, welcome back to that connection with print out.
Yeah, it's friendly, isn't it?
Of course, I'll error and log to the appropriate place if something goes wrong with sending that message on that connection.
Yep.
And then I'm going to create, it looks like, a new reader. So that's presumably I created a buffer of some kind. A reader.
Yeah, if you have an I/O reader and you would like to read from it in a buffered way, which is usually a good idea over the network, Buff I/O reader will do that for you.
Connection must be an I/O reader.
Yep.
In this case.
Everything's an I/O reader, unless it's a writer. That's so handy, isn't it?
I'm then going to go ahead and set my username to the next, results. The next time somebody hits enter on the connection or returns an end of line or whatever /n refers to exactly, but results when you hit enter on the keyboard. I'll be reading that value out, and I'll be calling that the username.
Yeah, so this is one of the nice things that Buff I/O reader does for you, is you can just say, give me a string up to a certain character. New line is common. Otherwise, you'd have to do that reading yourself, using the primitive read method, which is a bit of a pain. So this is kind of neat if you just want to say, I have a reader and I just want to suck a string out of it. Here it is. I don't know how that can...
So in this case, it would be possible to have an empty username. Is that accurate?
Yeah, I think so. If they just hit enter, you'll just get empty string, but that's perfectly cromulent.
Sure.
I guess if the user disconnects before they've typed new line or something else goes wrong, we'll get an error. And then what do we do?
I'm going to set my username to, I'm going to trim off any extra space that somebody might have entered during the process of entering their username. So if they put a bunch of spaces after their username.
Yeah.
That's I assume that's what trim suffix does.
Trim suffix actually trims whatever suffix you want. So in this case, new line.
Got it.
Because read string reads up to and including the new line, and actually we don't want the new line to be part of the username, so we chomp it off.
Oh, gotcha. Yeah, okay. I was assuming it was doing, that makes sense. You're telling it what to trim off.
Yeah, we could have trimmed spaces as well if we wanted to.
And then we are creating a pointer to a connection that we are also creating. That is a struct I saw up above a little ways that includes essentially a pointer to the connection that we created when we got back from accept, and the username that was just created.
Yeah. So we're really just wrapping that net.con so that we can store the username on it, aren't we?
Yep.
We need to remember the username.
Yep, and we're going to send that to our register channel, or send that over, or signal that over. I'm trying to get the right words for sending stuff over a channel, but
Yeah.
we're going to send that to that particular channel.
Yeah. So if anybody hasn't seen that particular statement before, that's called a channel send statement. So this arrow says, here's something, here's a channel, and here's something we want to send to it. So we can see from that it's a channel of pointers to connection, which makes sense. That's what we have. We wouldn't be able to send any other type of value to it. And it's not buffered, so we do block on sending to that until someone's ready to read from it. But that's okay, because there is someone ready to read from it, as we'll see. So Thibaut, would you like to take us through the next bit?
Yeah, basically it's the place where we have a loop that is blocking on the different channel, because the run function is just like the orchestrator of the chat server. So in fact we've got a for loop with this for select case pattern, and in fact on each iteration we are watching on each channel which one is ready to push us a message, let's say.
Yeah, so we're actually doing two things in the server, aren't we? We're listening for connections, which is this forever loop, and we're also passing messages around, which is this forever loop. Has anybody seen select statement before, apart from Thibaut? Anybody know what it does?
Never used it. Seen it in reading code, but never used it.
Yeah. So it's a really useful thing in Go, that if it often happens that you have a bunch of channels and you're essentially acting on messages received from those channels. So you just want to, well, suppose you just had one channel, you could just sit there blocking on a channel receive, saying, give me a message from the channel. As soon as something comes in, okay, now you can activate. But there's a bit of a puzzle about what if you have more than one channel? Because you can't block on listening to two channels simultaneously. Or can you? Well, yes, you can. You can use a select statement, which is like a switch statement in that you have cases, but it's a special kind of magic switch statement where the cases are channel receives. You can see in each of these cases we're receiving from some different channel, register, broadcast, or unregistered. And what that means is essentially we'll block here until something appears on any of those channels. Whichever channel has something for us first, we'll go straight to that case. Now we're inside the case, so now we have message, and then we can do something with it. So for select is a really common pattern with servers for obvious reasons, because we don't have anything to do unless there's something to do, and what we need to do will be determined by which channel we receive on. So carry on, Thibaut.
Yeah. So in the first channel is the register one. So once we get
That's new connection, right?
the new connection that was sent by the listen Go routine, we receive this message, and we're gonna update in fact this map, which stores the active user. In fact, it's storing the connection. And we saw previously that this map is accepting connections and strings, and in fact the string is the username. So we are mapping the connection and the username of the user within this map that is inside the server. So in fact it's like our active list of user and the related connection.
Great. So one question that might occur is, since we essentially want to add the new connection to a map on the server, why don't we just do that here? Because we're a method on the server, so we have access to it. Why don't we just update that map directly? You can't answer because you know. Anybody else want to answer?
Can you say that again?
Why go through this dance of sending something on a channel here and then receiving it over here and updating the map? We could update the map right here, couldn't we? We have it. What's the problem?
What? You can't do that with multiple channels, could you?
Well, we're saying why do we...
Updating the map right there would be easier to let go, handle the traffic that's coming in because it knows how to optimize it.
Yeah, well, we're asking why have a channel at all? Why not just simply put s.clients equals new connection? You know, what problems could that cause in a concurrent server?
Well, that's what I was saying. If you don't do the channel, you're creating a bottleneck. You can't post the messages as fast as they come. Say 100 people are connecting at once. That's a small number for a server, of course. But can you post it and map 100 connections and all of their messages as quickly as the Go routine who's waiting to listen for it can?
Yeah, I know what you're saying. You're basically on the right lines. Anybody want to expand on it a bit?
It seems like it's about receiving the concurrency. You're allowed to pay a whole bunch of users could come in and be creating usernames or connections, and that is allowed to happen concurrently. It's the result of what happens, right? So
yeah.
I created a username and a connection. I'm going to send it back. I don't want to try to have my map being updated concurrently. I want to handle those one at a time and update my map.
Yeah, that's absolutely right. It was a bit of an unfair question, really, because there's no concurrency problem with this as it stands, because this is one Go routine and there's only one listen Go routine. It loops forever, accepting connections, registering them, and then listening for another one. So as long as no one else touches the client's map, that'll be fine. No data races. But of course they will be touching that map, because when we broadcast a message, for example, we'll need to read that map. When somebody disconnects, we'll need to delete them from the map. So that would be a big problem. So if you didn't have channels, what might you do to avoid that kind of data race?
You'd have to lock the map when you did something to it. You have to use a Mutex.
Yeah, that's right. So if you have some shared data between multiple Go routines, you are just not allowed to access it concurrently, or to be completely exact, you can all read it concurrently. As long as all everybody's doing is reading, that's absolutely fine, no problem. But if anybody is writing to it, or could potentially write to it, now there's a big problem. So concurrent reading and writing doesn't work for complicated reasons, but common sense sort of tells us that could be a problem, wouldn't it? Everybody's trying to grab at the same location in memory and do things to it. One person's trying to change it while someone else is reading it. It's going to end up being a nightmare. And of course, with multiple processors, which we all have probably, each CPU has its own on-chip cache, which is caching a bit of memory that it's talking to. So imagine if, CPU 0 is modifying the map in its own cache, and CPU 1 is reading the same map, but it's now out of date from its own cache, and that's clearly a nightmare. So one way that we can prevent that is to use the mutex, as Tom said. So you could just require everybody to obtain the mutex lock before touching it. So we might say, s.client mutex.lock, and we would block. We could require Go routines to lock a mutex before they access this shared map and then release it. What would be the problem with that scheme, or why would that not be ideal? Anybody know?
then you would be required to do it every place that you want to do anything with that map.
Yeah, you could forget, couldn't you? It'd be very easy to just start accessing it and then realize later, oh my god, I forgot to get the mutex. Or somebody who's using your library, they might not even realize that they're supposed to obtain a mutex. There's no way to make it compulsory. That's the point, isn't it? And there's another problem. We're supposed to be concurrent here, but if there's an exclusive mutex, then that's goodbye to concurrency, isn't it? Everybody has to basically queue up waiting for that lock before they can do anything. So that really is far from ideal. So Go has this really nice concept of channels, which is just, the proverb says, don't communicate by sharing memory, share memory by communicating. That sounds neat, but you need to unpack it a little bit for it to actually make sense. So what they're saying is, don't do that thing of having global shared data protected by a mutex to exchange information between Go routines. Instead, communicate over a channel, and then there's no shared memory involved. You simply send the value out of your Go routine, it goes through some magic inside Go, and it comes out the other end here, and the arrows kind of convey that, don't they? And the point is, of course, channels are concurrency safe. They actually have a mutex inside them, but you don't need to do the paperwork, if you like. It's all taken care of for you. So, via that digression, sorry Thibaut, you were explaining what happens here, so please go on.
So, in fact, once the map is updated, we're just logging, on the server that we registered a new client connection. And then what we're doing is that we are creating a string that notifies, in fact, it's a kind of notification that a new user has joined the chat. But the first line is just we're creating the string, and then we're sending it on the broadcast channel. It's the second line.
Yeah. So we know what that is now, don't we? We've seen the channel send statement before. Now we're talking to the broadcast channel, which is just a channel of string. And we know it's buffered, so we won't block here. We'll just go straight on to the next bit.
Yeah, and we're starting the handle function within its own Go routine.
Yeah. So let's come back to that and just look at what happens in the broadcast case. So we know how this gets triggered. We've just seen it. When somebody joins, we broadcast the message saying Bitfield has joined. Now here's where that comes out. So what happens here? We have a list of clients, which is our map of connections. We're going to range over it. For each client, we're going to print the message to their connection. So fprint is just like regular print, except it prints to some IO writer. Here's our writer, it's the network connection. And if there's any error for whatever reason, sorry, go ahead.
I apologize. What does fprint return other than an error? Is it like a success or failed type of thing?
It's
how many bytes or something?
Yeah, it's just like write on a writer. It returns how many bytes were successfully written. So perhaps none. Maybe the person just disconnected while we were talking to them. So you can imagine if you're printing to a file or something, you might like to know that actually that you got cut off before you finished writing the file. But I think this is unlikely. So that pretty much covers broadcast, doesn't it? And it's actually really easy. I mean, you sort of feel like instinctively that should be difficult. Broadcasting concurrently to a ton of connected network clients, but it's actually so easy. We have them all in a map. All we do is just, to each one in turn, just print the message. And the last thing we do is unregister. So if somebody disconnects, that will come through here. So we just use the built-in delete function to remove them from the map. So that's nice and easy too. So this is actually the whole thing, which is kind of nice. Like, this entire server fits on one page, which is really neat. And it's probably not as complicated as you thought it might be, right? Or at least not as lengthy. The one thing
that's true. Yeah. Definitely simpler than I was expecting.
Yeah, and it wasn't always that simple, was it, Thibaut?
Yeah, I had a lot of refactoring to have just this simple server. I think it's more than 100 commits I saw on the Git repo earlier today.
Yeah. So of course you started from nothing, and it got longer and longer and longer, and then it gradually got shorter and shorter and shorter till you ended up with this. And that's really common, isn't it? So it's tempting to think, when you look at projects on GitHub, or really famous and well-known Go projects, and you look at the code and you think, wow, this is really clean and nice and simple and straightforward. I'm sure they just sat down and wrote this, like a boss. But that's really not what happens. All of those projects, they probably started out by just bashing out something which vaguely worked, just a main.go which does something, and then started refining that into a library, and then figuring out how to break it up into different little bits, and then saying, well, I don't like the way that bit works, it's not very convenient to use, I don't think this method should be here, it takes too many parameters, or how can I make it so it doesn't need to take any parameters? And if you're really good, eventually you get to a point where it looks as polished as this. And the only bit we haven't seen is handle, which is effectively, this Go routine, there's one of these for each connected user, and again we have an infinite for loop. Makes sense. We can stand it as long as they can. So we want to read something from them, and we just block until we have. If they've disconnected, then we'll send their connection to the unregister channel. So that's how that happens. Assuming we successfully read a string, we'll just prepend their username to it, and we'll broadcast it. So that's really rather beautiful. And if you think about it, every kind of network server you could imagine is basically like this at some level, isn't it? I mean, this isn't fancy, you could imagine fancying it up a whole lot more. You could have things like, you could have commands that you could give the server, using some special prefix like /, like if you've used IRC, the / commands in Slack, you've got the same thing. You could imagine remembering information about users, ask them to set a password and then they can log in. They can maybe get private messages and things like this. You could have multiple chat rooms. You could run it in a web browser. You could do anything you like, but the core is there, isn't it?
Yeah. You can have also message history.
Yeah, absolutely. So Josh of this parish did a coding test where it was a concurrent calculator chat, which was quite interesting. So it was a bit like this, except that instead of messages, you just send arithmetic expressions. And so you put in 2 plus 2, it calculates the answer 4 and then shows it to everybody who's connected. So it's like a chat room just for mathematicians. And that was really interesting, and he did it as a WebSockets server, so he had a little web app in the browser that does that. But, basically, if you look at his code and ask him about it, he'll show you. It looks exactly like this. And When you look at examples on the web of chat servers and things, they probably take roughly this form, and that makes sense because it's not, not suggesting Thibault stole the idea. I'm saying this fundamentally is the only way to really do this, isn't it? I mean, there are other less good ways, but this is the most optimal way. We definitely want to use channels. We have to have a broadcast channel, we have to have a list of connected clients, and we need some way to register and unregister. And we're going to have some infinite for loops like this. So I think it would be really hard to write this in any significantly different way from this. But if you know a better way, I'd be interested to hear about it. So, okay, so we have a minute or two left. So anyone like to ask any more questions about it? Well, we've got the author on the spot.
Maybe a small question. Why name your return values? So like list and serve has a named results.
Oh, here, I didn't even realize that I named the results. Actually, usually I don't, because I don't like, I think it's called naked returns.
Yeah.
I think it's
well, a naked
sometimes
return is
confusing.
if you just use the return statement with no arguments.
Yeah.
Because you can do that if you have named return parameters, but you don't have to just because you have named parameters, if that makes sense. And you shouldn't, but you mustn't.
So basically here I named them, but usually I don't.
Yeah. Why do we name return parameters in general? What's the point of that?
Maybe if we have 2 or more parameters that have the same type.
Yeah, exactly. It's just documentation, really. It's just saying to someone who's looking at your documentation and they only see this. Error is clear. We can sort of guess what that's about. But if you returned a string, for example, well, what string? Why? What does it mean? What's in it? We have no way of knowing. If you gave it some helpful name, that would signify to the person using what that means. And there's a technical reason as well. If we wanted to do some kind of cleanup using a deferred function, maybe we want to modify the return value. If you think about it, suppose you had some state which you needed to clean up before the server can be shut down. Flush its state to disk, for example. You might want to do that, but there could be a problem with saving the state. You might run out of disk space or just error or something. And in that case, you could modify this return value to say, uh-oh, there was an error shutting down. And the only way you could do that is if it had a name. So that's the other reason. So yeah, to answer your question, Tom, I think you don't need to do it here. And Thibault's right. In general, I don't do it just for the sake of doing it. I only do it if I think it needs a little extra documentation to explain what it's about. Does that answer the question?
Yeah, for sure. Thanks.
Excellent. Okay, shall we wrap it up for today then? This has been really interesting, and thanks Thibault for this project and for helping explain it to us.
Thanks for the Code Club and your mentoring. I mentioned it in the README because it was really, really great.
Yeah, well, that's very kind, but I didn't really play a big part. All I did was look at the code and say, I don't like that, change it, make it better. And you did, so it's all you, buddy. Well done.
Thanks.
Okay, thanks everyone for being here, and I'll see you next time.
Bye.
Bye-bye.